Welcome to in 5 minutes. Next is the bias series clipper again, but the negative. It will clip the negative part of the input signal while it will reshape the positive half cycle. How you can see over here in the diagram, again series clipper, the negative part of the DC bias is connected to the positive terminal of the diode, hence this 2 volt will reverse bias the diode. Whereas in positive half cycle, this supply voltage, the direction of the input voltage will try to forward bias the diode, but this 2 volt will not allow the supply VI input swing to make the diode forward bias until and unless you are overcoming 2 volts. So what will be the equation, that is KVL from input to output? From input to output terminal will be VI minus 2 minus VO equals to 0. So VO will be VI minus 2. So from where to where your VI is varying? In positive half cycle you are varying your VI from 0 to 4 volts, right? So VI will be initially 0, then VI will be 1, then VI will be 2, then VI will be 3, then VI will be 4. So for this corresponding inputs, what will be our corresponding output? For 0, it will be minus 2. Since it is minus 2, it will reverse bias the diode, so your output will be 0. For VI1, it will be 1 minus 2, again minus 1. This is reverse biasing the diode, so you will get output as 0. For 2 minus 2, 0. Again the diode is not forward biased because you require the voltage greater than 0.7 in order to make the diode to be forward biased. But practically we are considering above 0. So after 2 volts, say 2.1, the diode will be forward biased because your input voltage is greater than 2 volts, that is say 2.1 onwards. So till 2, your output remains as 0. Now see here, when your VI is 0, 1, 2, diode is reverse biased, diode is reverse biased, your diode is reverse biased. After 2 volts, the diode becomes forward bias because you will get positive 1 volt. This positive 1 volt will be applied to the positive terminal of the diode. Diode will be forward bias. The current will flow to the load resistance and you will get output VO as 1 volt till 4 volts. After 4 volts, again the voltage will decrease 3, 2, 1, 0. So for those correspondingly, you will get different readings as shown in the slide. Now the final output. How to draw the waveform? We first consider the minus 2 volt voltage level. You are getting output after 2 volts, that is from 2.1 to 4 volts. So when you look here, minus 2, your 0 level, if it is shifted over here, so 0, 1, 2, 3, this is your 2 level because we are shifting the 0 level below. So you will get maximum output, it is going till 4 volts over here because since your 0 level is shifted below because of the DC supply voltage, 0 level is shifted. So after 2 volts you will get output again till it comes to 2 volts and maximum swing is 2 volts, that is 3 to 4 volts. Then these yellow lines are just the projections. This I am showing the 2 volts over here, after which you will get the output, that is you will get output only for this cycle which is drawn over here. Again what will happen in the negative half cycle? This voltage is reverse biasing the diode and again you will try to reverse bias the diode. So what will happen? The diode will remain off entirely after 2 volts because these 2 volts will again make the diode off and it will be switched off in the negative half cycle. So you will not get any output after 2 volts. So your output will be in this format. You will get output as a wave only in this part. And how to draw the transfer characteristics? After 2 volts you are getting the output. So after 2 volts, as your input varies, your output is varying. So after 2 volts you will get the output. Below 2 volts the output is 0. So till 2 volts it is 0. After 2 volts it is going to 4 volts. This is the voltage transfer characteristics. You can draw the voltage transfer characteristics for all circuits and you can design the circuit from the given voltage transfer characteristics also. That is if you want the output after 2 volts. So what should be the position of the source and the diode, that can be decided from the voltage transfer characteristics also.